part one of this video, I went over an introduction to zone pressure diagnostics. I also went over non-modifiable zone analysis. In part two, we're going to look at modifiable zone analysis, which is much more powerful. It requires a calculation aid. There are a number of these around. I'm going to talk about some of them. We are going to use the Residential Energy Dynamics ZPD tool, which is a free online tool available to you anytime, anywhere, as long as you have a browser on your computer device, smartphone, tablet, laptop, or desktop computer. The modified zone analysis allows the user to determine the flow through the zone, looking at each of the two pressure boundaries individually and also together. We set up the blower door and we look at the pressure differences from the house to zone and the zone to the outdoors. Then we take a reading of the whole house CFM 50 in its initial configuration. We might call this normal. Then we modify things by creating a hole, or occasionally we can close a hole. We do this usually in the most resistant of the two pressure boundaries. Then in that modified condition, we look at the pressure differences again. Then we again take the whole house CFM 50 in its modified condition. And that then allows us to determine the CFM 50 flow through the pressure boundary from the house to the zone, and through the other pressure boundary from the zone to the outdoors, and with the two of them in combination, which we can call through zone or total path. And then for the house to zone and zone to outdoors, we can determine the square inches of leakage through those pressure boundaries. This is a very good tool if you're out there air sealing an attic, for example, or air sealing a wall between an attached garage and a house. And it's a very good tool for quality control inspectors to determine whether a house has been weatherized correctly. I want to put calculation aids used for a modifiable zone analysis in perspective. Historically, the add a hole method and the open a door method have been used. Less important has been the vent method, which fell out of favor pretty quickly because of its inaccuracy. I'm going to show you some calculation aids that have been used for add a hole and open a door. We recently, the folks at Residential Energy Dynamics, put together the red ZPD tool, and we combined the add a hole method and open a door method into one method, which is quite accurate, very easy to use. It does not require very many inputs to use the tool. We will use the red tool in a couple of examples, so I'll walk you through each one, and I hope by the time we're finished you feel quite comfortable with the red tool. This chart has been used probably by many of you for ZPD analysis in the past. It was put together by Colin Olson and Anthony Cox in 2006. It is based on the advanced ZPD field study and analysis that was done in 2001. Usually this is laminated, has two sides. One side covers hole added from the house to the zone, and the other side covers hole added from the zone to the outdoors. And in the yellow here you see that we have house to zone pressures, and here in the blue zone is zone to outdoor pressures. We use the chart pre and post. We do a whole house CFM 50, we enter that, and the only result that this gives us is the maximum reduction or the total path or through zone leakage. It's the only thing it gives us, so it's rather limited in that regard. This chart was also put together by Anthony Cox and Colin Olson in 2006. It is the open a door chart to contrast it with the add a hole chart, the colorful one we just looked at. This is usually laminated also and two-sided. This side that I'm showing you is for opening the door from the garage to the house. The other side is for opening a door from the garage to the outdoors. If you use this chart or the previous colorful chart, you get exactly the same answers as you get with the red tool. The advantage of the red tool is that it's a bit easier to use. It combines both the add a hole method and the open a door method, so you just need one calculation aid. And as with this one and the previous colorful chart, it also reports the uncertainty of your numbers. We'll look at that more carefully when we do an example with the red ZPD tool. These are the most common zones for which we use modifiable zone analysis. The first two are by far, I think, the most popular: attics and garages. Sometimes it's used in basements if you want to know how leaky basement walls are to the outdoors. That can be very useful. Or for crawl spaces if you want to know how leaky a crawl space ceiling is to the house, or for some reason a crawl space wall to the outdoors. So very good analysis for all of these. I think it's probably used most for attics for determining the effectiveness of air sealing and for quality control inspections, and for garages for the same thing, but in this case the effectiveness of air sealing the common wall between an attached garage and a house. I want to talk a bit about the use of your digital manometer or manometers for ZPD. You need a digital manometer for a non-modifiable zone and for modifiable zone analysis. In each case, you must measure pressure differences across pressure boundaries. I know when I was learning about ZPD, the most difficult part for me was coming to grips with the right way to hook up the manometer. Where do I put the hoses on the manometer? How do I set the manometer up? Where do I put the hoses in the house? Do I put a hose outside? Do I put it into the zone? What do I do? This is a bit beyond the scope of this training, but I do want to talk about it some to orient you. The best way, I think, to learn this is to get out in the field with someone that already knows what they're doing and listen carefully to their instruction regarding the use of the manometer. Not only how to set it up, but where to put the hoses on the manometer. There are two manometers out there that are common. This one is a DG700 from the Energy Conservatory, and the other one that is out there that is quite common is the DM32 from Retrotech. Both are available with Wi-Fi. Both are very good options. I do not favor one over the other, although I do know more about the DG700 from the Energy Conservatory. Because I think this is the most common one out there, I'm going to spend most of my time just going over some of the issues with setting this up correctly for ZPD. First of all, it's important to set the manometer up as pressure. Here you see PR/PR. That means you'll have pressure on this register and pressure on this register. Both of the manometers, the Energy Conservatory, pictured here, and the Retrotech manometer, are essentially two digital differential pressure gauges, one on one side of the gauge and another on the other side of the gauge. Something that is very important for me is to think of this pressure tap with reference to, that's what WRT is, this pressure tap. And likewise over here, this pressure tap with reference to this pressure tap. Remember, always with a manometer like this, you are measuring pressure differences from one space to another. When you set up the digital manometer for your whole house blower door test, you are measuring one zone, the inside of the house, with reference to the outdoors. So that is a pressure difference. We are doing the same thing here, pressure differences. So if we want to measure a attic as a zone with reference to the house, we would put a hose on this pressure tap, and then we would stand in the house, and this pressure tap would be reading the house. So that would give us the zone pressure with reference to the house pressure, while simultaneously the blower door is depressurizing or pressurizing the house, probably to 50 pascals. Okay, let's have a little digital manometer fun here. First of all, we've got the blower door operating. It is depressurizing the house to a level of 50 pascals. That is measured on the left side of this manometer. We have the open tap, which is the inside of the house, and we have a green hose connected to the outdoors. So we are measuring a pressure differential from the house to the outdoors. And on the left side of the manometer, the readout is negative 50. On the right side of the manometer, we've got an open tap. That's the house, with reference to the zone or the attic. And the pressure difference there when the blower door is operating is negative 32 pascals. As you will see when we use the red tool, it's important to include the sign. Now, without moving our feet, we can find out what the pressure is from the zone to the outdoors. We already have a reading to the outdoors, and we already have a reading to the zone. So what we do is take the blue hose and merely shift it to this tap. So now we have the zone with reference to the outdoors, and we see the reading on the manometer of 18. So that is mimicked right here with the text I wrote, negative 18. And the pressure from the zone to the house, going back to the other manometer setup, is negative 32, as you see here. Usually with zone pressure diagnostics, we want to try to create as best as we can a pressure from the house to the outdoors of 50 pascals. With the red tool, however, that is not an absolute requirement. If you cannot reach 50 for whatever reason, usually because the house is too loose, you can still go ahead and do zone pressure diagnostics. Before we leave this topic, just one more thing. If you are able to get your hands on two manometers, it makes things a bit easier. You can keep one at the blower door, and you can walk around and do your ZPD testing with the other one. Of course, it is possible to do ZPD testing with just one manometer. You use it at the blower door, then walk around with the same one and use it as you are doing your testing. We're now going to go through a modifiable zone example using the Residential Energy Dynamics tool. This example will be to the attic, using the attic as a zone. This is very common, and what we will do is open an attic hatch. We could just as well open a door at the top of a stair that goes to an attic. As I've already mentioned, to determine the leakiness of a pressure boundary around a zone, we must determine the CFM50 flow through each of the boundaries. And if we know that, we can then convert that to the square inches of leakage. That's a very powerful analysis. This is done by modifying the boundary, one of the boundaries, and usually what we do is modify the one that has the greatest resistance to airflow, that is the tightest one, which is either the zone to the house or the zone to the outdoor boundary. Some guidelines here. First of all, create the hole in the tighter of the two pressure boundaries, that is, open a hole such as an attic hatch or open a door such as a door to a garage. As you know, with the red ZPD tool, it is possible to close a hole or close a door. I've only done this once in my time in the field. It's very unusual, but it is good to have that capability with your calculation aid. Secondly, try to create a significant pressure shift when you open that hole. For example, if we are testing an attic and across the attic floor we are getting a pressure of 40 pascals without the hole open, without the attic hatch open, we are better off to try to significantly change that pressure, say from 40 to 15 with the attic hatch open, as compared with 40 to 35 with the attic hatch open. So in almost all cases, if you're dealing with an attic hatch, all you have to do is shove it aside, put it up in the attic out of the way, and go ahead and do your testing. Thirdly, try to create a significantly modified CFM50 for the house with the hole open or the door open. And I will show you more clearly what this means when we look at the red tool. All right, let's do an example with CPD to an attic. We'll treat the attic as a zone. Here we have the setup. We're going to use one digital manometer because most of you will only have one. We set up the blower door, and in this case we are going to depressurize the house to 50 pascals. You could also pressurize. We take a hose and we put it up in the attic hatch, and then we close the attic hatch again. Make sure that you don't totally block the hose or crimp the hose when you do this. It's a good idea if the hose is at least 3 feet away from the attic hatch to keep it out of any airflow. Of course, this drawing does not represent that very well, but that's a problem with my drawing. So we have on the right side of the digital gauge, we are measuring the house with reference to the attic. Then on the other side of the gauge, the left side, we're measuring the house with reference to outdoors, and we're verifying that we do have 50 pascals of pressure. And when we do the blower door test in the initial configuration, which is this one, we found that the whole house CFM50 is 2400 with the hole closed. Now I'll show you how I enter these numbers in the red tool. Here's the top of the red tool, not the whole thing, but most of it is here. I'll scroll down. Attic at the Jones house is what I'm calling this. The blower door test type is depressurization. We could choose pressurization. I am not now going to use the advanced inputs. I could if I wanted to, of course. And let's assume that we are using the baseline feature of the digital gauge. So the blower door off pressure, or the baseline pressure, is 0. Blower door on is 50 pascals, and here we must enter the negative sign because we are depressurizing. If we were pressurizing, we would not have to enter a sign. And here we then have the delta pressure. It does the subtraction for you, a negative 50. Now, with our house to the zone pressure, we found that that's a negative 32, and that is right here, a negative 32, and input here. Again, we're assuming we're using the auto baseline feature of the digital gauge, and we put 0 there, and negative 32 here. Again, the sign is important. And we are inputting the house with reference to the zone rather than the zone with reference to the outdoors. And then finally, we need the whole house CFM 50. That value is right here, the whole house CFM 50, and that is entered right here in this input box. And as I've said already, you are able to change the units if you wish to do so. The zone leakage ratio, the zone to the house with reference to the zone to the outdoors, is 1 to 1.5. Now that we've looked at the initial zone configuration, we're going to look at the modified zone configuration. In other words, how are we going to change things so that we get different pressures and a different whole house CFM 50? We compare that with the initial case, and it gives us the results we need with the use of our calculation tool. We are still measuring from the house with reference to the zone. We have a blue hose up in the attic. In this case, for the modified zone configuration, we remove the attic hatch totally, so we have a lot of air flowing down through. When doing that, be careful that you don't bring cellulose or other debris down from the attic. We still have a hose to the outdoors that checks to see if we are at 50 pascals. Of course, once you open this hole or open a door, you're going to have to increase the revolutions of the blower door to keep the house at 50. Now let's take a look at how this is entered in the red tool. Here is the modified zone configuration in the red tool. Here's the initial, by the way. Both can be seen at one time. We are opening a hole or a door located between the zone and the house. We have the choice of the zone and the outdoors. Remember, we want to open this hole in the pressure boundary that is the most resistant to airflow. In other words, the pressure boundary with the highest pressure difference in pascals. The type of modification, you're almost always going to use add a hole or open a door, but you can close one. So based on our example, again, if we use the baseline, this is 0. The blower door is depressurizing to 50 pascals. Here is the pressure difference. House with reference to zone, there is a choice here, and we now have 15. We started at 32. We shifted the pressure down to 15 by opening the hole. That's a pressure shift of 17. That's pretty good. And we end up then with a whole house CFM 50 of 2950. That's an increase from 2400. So going back to the example, you see this is what we've got. And just to show you, I'm going to go back to the initial zone configuration. This is where we started. This is the modified zone configuration. And with the entries in the tool, this is what we have. The initial zone configuration, those numbers are entered here. The modified zone configuration, those numbers are entered here. And if I scroll down, you see the results. What we have for the house to zone leakage in units of CFM 50 is 1400 plus or minus 600. And in leakage area, that's approximately 140 square inches plus or minus 64. This is the uncertainty as a percentage. From the zone to the outdoors, we have 2000 CFM 50 as a flow plus or minus 650, and this is the square inches of leakage plus or minus 72, and the uncertainty and the through zone, sometimes referred to as the total path, is 1,000 plus or minus 410 with a 40% uncertainty. So these are very powerful results. We can do a lot with these. Just a few words about uncertainty over here, and the uncertainty absolute numbers listed after these values. Zone pressure diagnostics has always had uncertainty attached to it, but what we chose to do here is show you what it is. And I wouldn't worry about this uncertainty. There are things you can do to lower these numbers, these percentage numbers and the values here. The ones here are not really out of line. They're in a pretty good range. There can be uncertainty percentages and values that are much larger than these. For example, if your pressure shift is less than 17, we have a pressure shift here of from negative 32 to negative 15. That's a pressure shift of 17. If the pressure shift is less than that, these uncertainty values will go up. And there are other things you can do to make the final result more accurate. And that would mean that these uncertainty percentages would come down. Finally, what we find here is the percent of the whole house leakage passing through the zone is 42%. That is this value right here, 1,000, and that is 42% of the initial whole house CFM 50. So that's where that comes from. Now on the following slides, I'm going to explain what these result values mean and how you can use these to analyze how you've done with air sealing and to conceptualize them better. I want to give you a little more information about what each of these values mean in the results. Notice the title is the results for initial zone configuration. The only reason we modified the zone was so that we can find these results for the initial configuration where we started. First of all, the house to zone is 1,400 or 140 square inches. The zone to the outdoors is 2,000 CFM 50 flow rate and 210 square inches. And the through zone is 1,000 CFM 50. Now these are represented on this illustration. You can see the zone to the house or house to zone either way. We have 1,400 CFM 50 flow rate and approximately 140 square inches. For the outdoors to the zone or zone to the outdoors, we have 2,000 CFM 50 flow rate and approximately 210 square inches. Notice that the square inches is pretty close to dividing the flow rate by 10. Not exactly, but almost always quite close. And the total path is 1,000 CFM 50 flow rate. We don't divide this by 10 or try to determine the square inches because this is for both pressure boundaries, the roof, gable end, and the attic ceiling. And notice for the initial configuration, the whole house CFM 50 is 2,400. So if we look at these in order, first of all, the house to the zone, zone to outdoors, and the through zone. A few details about each one. This is the zone to the house or house to zone, same thing, of 1,400. This is the leakage through the pressure boundary, that is the attic floor, as if the other pressure boundary, the roof and gable ends, were totally removed. Now, this, of course, is not going to happen, but this gives us the capability of being able to divide the number by 10 and get approximately the square inches of leakage. And that's quite powerful. Of course, we can do this pre- and post-weatherization and find out what the pre-weatherization square inches is, and then find out what the post-weatherization square inches is. And keep in mind that every square inch that the workers in the attic seal will reduce the flow rate, the CFM50 flow rate, through this boundary, through the attic floor, by about 10 CFM. Then for the zone to the outdoor, or outdoor to zone value, this is the flow through the roof as if the ceiling were totally removed. Of course, this is not going to happen, but again, it gives us the capability of finding the approximate square inches of leakage. We have 210, and this gives us a very good idea, perhaps the best idea possible, of what the effective attic venting is. We don't have to go measure it with a tape measure, but this would include the vents that are already in place, and it would also include any leakage in the soffits and things where there are not intentional vents. And then finally, the flow through the zone, the through zone flow, or the total path of 1,000, this represents the combined leakage of both pressure boundaries, the ceiling gable ends and the roof acting together, or in other words in series. Both of these impose resistance to airflow. Therefore, the total path CFM50 is always less than either of the other two numbers. And as we have already gone over, the total path number of 1,000 gives us the idea of the leakage through the top of the house. And there's an example here, 42%, which is portrayed in the red tool results. This means that the leakage through other parts of the house would be 2,400, the whole house leakage, less the leakage through the top of the house gives us 1,400 CFM50, which is the leakage through the remainder of the house. Now again, here are the values in the red tool, and I just went over and explained these. And these are the values, again, maybe a little easier to understand them here because they are in diagram form. Now again, here we have the house to the zone is 1,400 CFM50 flow. The zone to the outdoors, the other pressure boundary, is 2,000 CFM50 flow. And the through zone or total path is 1,000. Again, this is always going to be less than either of the other two because it's taking into account the resistance of airflow through both of the pressure boundaries, not just one. Now we're going to look at another example, modified zone to an attached garage. For this, instead of opening a hole, we're going to open the door from the house to the garage. This door is in the common wall between the house and the garage, a very common configuration. For this test, the door between the house and the garage remains closed for the initial zone configuration readings of pressures and whole house CFM50. The size of the opening, the size of the door, does not have to be measured. That's the case with the red tool, no matter how you're doing the testing. With the door between the house and the garage closed, we'll measure the whole house CFM50. We will say that's 2250. We will then measure the house to zone pressure difference. We'll say that is negative 32. Remember, we're depressurizing the house. You could just as well pressurize the house, in which case you would not enter negative in the red ZPD tool. And then finally, measure the zone to outdoor pressure. Let's say that's negative 18. Now we open the door between the house and the garage for the modified zone configuration and enter the appropriate numbers in the red tool. And we get a whole house CFM50, we'll say, of 3,000. The pressure from the house to the zone in a test like this is best if it's very close to zero, which means the pressure from the zone to the outdoors would be very close to 50. That increases our accuracy, gives us a very good pressure shift. Let's fill in the red tool now for the example that I just described. We have up here in the description attached garage at the Jones house, and we are depressurizing rather than pressurizing. Part of what this does, if you click on or select depressurization, it will check to see that you have put negative numbers here. And notice I've entered these values already. If I click on pressurization, it will check, it'll do error checking and see that, hey, you're pressurizing, you should not have negative numbers here. It will not allow you to go ahead until you fix your error. So this is an error checking feature of this particular RedCalc tool, and actually all the others also. So I'm going to go back to pressurization. Notice that the stop sign goes away and there's no error now. Soon I'm going to look more in detail at the advanced inputs to describe that, but let's assume that our blower door off or our baseline is 0. If you do not use the auto baseline and you do have a baseline pressure, just enter it. Say you have a -2 and then click outside the box. You'll see that changes things here, and that will slightly change your results. You don't have to worry about that too much, but if you do use the auto baseline feature, just enter 0 in the BD off or the baseline column. We've got 50 between the house with reference to outdoors, and the house with reference to the zone is -32. The whole house, CFM 50, with the door to the garage closed, is 2250. Then moving down to the modified zone configuration, we are locating the hole or opening the door between the zone and the house. That is the door between the garage and the house. Type of modification, we're adding a hole or opening a door. If you need to, you could open 2 doors, or you could also close doors by selecting the other choice here. When we open this door and do another whole house blower door test, of course now the house is leakier with this door to the garage open, so we go up. We've gone up to 3,000 from the 2250. We measure the house with reference to the outdoors again, and we're trying to hold that at 50, although remember, it does not have to be at 50. The house with reference to the zone now is 0. When you open the garage door, the door between the house and the garage, that is, it's a very good thing if you get a pressure close to 0 between the house and the garage. So then the results, I scroll down further for the results. The house to zone flow rate is 1060. The leakage area between the house and the zone is 110 square inches. This is the most important value here because we want to know how tight this pressure boundary is. These numbers give us a good idea with an uncertainty of 33%, which is pretty accurate. So we now have approximately 110 square inches leakage in this common wall between the house and the garage. Zone to outdoor in this particular case is really not all that important for us. We have a flow rate of 1550 and a leakage area of 160 inches, and the through zone or the total path is 800. That is the flow or the leakage through both of the pressure boundaries, the common wall and the garage envelope. The percent of the whole house leakage passing through the zone is 35%. That is, if you divide this 800 by the initial whole house leakage right here, you get a percentage of 35. I'm going to show you now the advanced input section of the red tool. The tool is still filled in with the inputs and the results from the garage as the zone. I will click on this box next to Use Advanced Inputs. You can see that this section of the tool opens up. I can click on it again and it closes up. When it opens up, it will use the values that are in that section of the tool to come up with the final results. If I unclick it, now those values will not be used in the final results, although they are still in place. So I'm going to click on it. House temperature, this is the inside of the house. The outside temperature, and the zone temperature. All of these will have an impact on the blower door readings and the flows because the temperature of the air has an impact on the density of the air. If the zone is well vented to the outdoors, this might very well be the case if it's an attic with ventilation. And remember, if you have questions about anything here, you just click or touch on the label and it gives you an explanation of what that input or result has to do with. If you think the zone is well vented like an attic, you go ahead and check that, and some things are done under the hood to make things more accurate. The building pressure exponent, this is a typical exponent right here, 0.65. That's the default value. If I were you, I would leave it there unless you have done a multi-point blower door test and you have an individualized building pressure exponent for the particular house. But the only way to get that is by doing a multi-point test. If it's a windy day, what you probably should go ahead and do is enter 3 baseline pressures at 5-second intervals. You can see what I have added here, a -3, a 0, and a -5. Now, if you do get baseline pressures like that at your blower door, this is for the whole house, that's a good indication that it's windy. Now, this will not have an impact on your actual results, but it will have an impact on the uncertainty. I'm going to scroll down here. And if you look at the uncertainty now, you notice these values are higher than they were. I will unclick Advanced Inputs in a moment and I'll scroll back down here. These values remain the same, but the uncertainty values such as this one and this one have gone up because it's windy. And if it's windy, it will have an impact on our results. They are less accurate or more uncertain. Now I'm going to unclick this. Those values are still there, but they're not now being used for the calculations. Notice how the uncertainty values have gone down. So if you use advanced inputs, I suggest you do so if it's really windy or if you've got low temperatures for most of us, this would be. Or you might use it if you're doing an attic and it's very well vented to the outdoors. Or if you have an actual building pressure exponent from doing a multi-point blower door test, I suggest you use advanced inputs. If not, just leave it alone. Life will be a bit simpler without it. Some final items about the Red ZPD tool. You don't have to measure the hole size. This is a big step forward in ZPD calculation aids. You can get rid of your tape measure, and that will save you a great deal of time. You may open or close more than one opening for testing. If you find that your pressure shift is not great enough when you open a hole, and if there's another hole to open, just go ahead and do it. Again, you don't have to measure anything. As we just went over, you can go ahead and use advanced inputs for greater accuracy. Enter the signs for pressures. If you're doing pressurization of a house, you don't have to enter any sign. You don't have to enter a plus sign. Just enter the number. But if you're doing depressurization test, and most of us do that because it's easier, you must enter the negative signs in front of your pressure differences. Notice the uncertainty values in the results table at the bottom of the red ZPD tool. You can do certain things to reduce those uncertainty values, and that's a good thing. It means your numbers are more accurate. For example, make sure that your pressure shift is significant. And as you use the tool, you will find other things that you can do to reduce the uncertainty. Related to that is read the user guide. The user guide has advice in it for reducing uncertainty and for using the tool. And finally, as I pointed out a couple of times, click or touch any input or result label to take a look at pop-up help. This will give you an idea of what that input or result is about. It will define it. And if it's an input, it will give you the ranges that your entries should be for that input. The more you use modifiable zone analysis, the better you will become at knowing when and when not to use it. Don't use it on extremely loose houses. Do obvious air sealing work first before you spend time doing ZPD. Otherwise, you'll just waste your time. You usually don't need to use it on extremely tight houses. These are already fine. Do baseload work and maybe insulation work. But air sealing is probably not that important, and certainly doing ZPD is not that important. It's a Goldilocks and the Three Bears thing. That is, if it's really loose, do some tightening first. Don't do ZPD. If it's really tight, don't bother with ZPD. But if it's somewhere in the middle, go ahead and do it. It's probably worth the time. And of course, as I've already mentioned, use it to find leaking pressure boundaries and to determine the effectiveness of air sealing pre and post. There are a few state low-income weatherization programs that have ZPD standards. More accurately put, they are ZPD targets. For attic air sealing in Wisconsin, the target is the through-zone leakage to the attic should be 10% or less than the whole house leakage. An example, if the whole house leakage is 2200 CFM50, the attic through zone or total path leakage should be 220 CFM or less. For the state of Maine, their attic air sealing target is based on a different value. The house to zone CFM50 should be 30% or less than the attic square footage. For example, if the attic is 1,000 square feet, that is the flat area, the zone to house CFM50 flow, based on the ZPD analysis, should be 300 or less. For an attached garage in the Wisconsin weatherization program, they have a target of 50 CFM flow between the house and the garage. And for the state of Maine, their target between the house and the garage is 4 times greater, 200 CFM50 between the house and the garage.